All right, we are live. Welcome everyone to the next Tech Excellence Meetup session. And the topic of today is Introduction to Sociotechnical Engineering by Yevgen Nebesov. This will be a very exciting talk. I look forward to it. Let's see what is the next. Yeah, we are Technical Excellence. Our vision is to raise the bar of technical excellence across the world. Here you can find our team of the organizers and the founder of Tech Excellence. And of course, we are online. You can find us on meetup.com/tech excellence. Of course, you can follow us on YouTube, LinkedIn, X, GitHub, and we also have a Discord community. Feel free to join. Huge thanks to our sponsors, Optivem, Mocha IT, and Codeartify, and to our partners, QE Unit. All right. So, as I already said, the introduction to sociotechnical engineering. Yeah. So, a few words about Yevgen Nebesov, the author of this talk. Well, he's a system architect from Germany. He is an independent consultant supporting software projects by helping them navigate through technical, organizational, and political complexities. He has an experience in various domains such as public transport, medical devices, and logistics, which all of them allow him to transfer best practices and innovation from one domain to another. Well, Yevgen, welcome to our show. We are super happy to have you. I'm going to hand over the microphone to you. But before that, I would like to ask the audience that if you have any questions about this topic or directly to Yevgen about sociotechnical engineering, then feel free to ask it in the YouTube chat section. And at the end of the talk, we will dedicate some time for the Q&A. We will answer, or Yevgen will answer all those questions. So again, Yevgen, welcome. I wish you good luck, and the microphone is yours.
Okay, thanks, Daniel. Can you hear me, by the way?
Yes, very good.
Perfect. Okay, then hello everyone. Also, welcome to the session from my side. It's a pleasure to speak here today. And today's topic is sociotechnical engineering. The word sociotechnical sounds sometimes a little bit exotic, but don't worry. I will explain step by step. I will try to speak for no more than 45 minutes, and then we'll have plenty of time for questions, if any, and discussion. Thanks, Daniel, for introducing myself. I also prepared a couple of slides, a slide for introducing myself. So I'm originally from Ukraine, from Kharkiv, but been living in Germany since 20 years in a small town, Bruchsal, where I'm trying to build a tech community by organizing IT meetups and other events. I identify as a systems architect and as politician, and in my work as a systems architecture consultant, I served customers in railway sector, in logistics, medical devices, and maritime navigation. And everywhere across of all these customers, I could observe the same scenario or the same pattern. There are two decision streams, one for the social and business stuff, led by the project lead, and another one is a technical decision stream led by lead architect. And these decision streams are like these British faucets where you have hot water for the right hand and cold water for the left hand. Of course, you can mix the water in the sink to the comfortable temperature, but it is much better to mix the water in the faucet and not in the sink. So, for example, the project lead might think about, well, I need an impossibility to ramp up the team to get the project a little bit faster, while the technical lead architect could think about, okay, I need data consistency among different persistence mediums. What they don't usually know is that their concerns are intertwined, and that they figure it out already when they set decisions in motion. And my dream always was to find something like this, a faucet where you can mix water before it goes down to the sink. And today with sociotechnical engineering, I want to introduce to you to such a faucet. But before we start, I want to share what actually happens in our organizations. Basically, when we think about software architecture, we usually think about making decisions, which are on the top level of this pyramid. So decisions answer the question, what is better? This kind of visible power. For example, we might ask ourselves how to split the system. But what we usually don't acknowledge is that before something emerges as architectural concern, it already passes through the filter of agendas and narratives, and these agendas and narratives are framed by the beliefs and our human comprehension. For example, beliefs, for example, agendas, they answer the question what matters, their hidden power, often institutionalized in our rituals and processes. For example, we have an understanding that durable architecture is important for us long term. This is on our agenda. That's why we usually try to think about how to split the system and answer the question what is better. And agendas themselves, they're based on beliefs, and beliefs define or establish what basically exists. It is totally invisible power. For example, some of us have a shared belief that architecture is a thing. For example, even though I say I identify as a software architect, I actually don't believe that architecture is a thing, because I would say architecture is an ontological legacy that constrains our beliefs, and we need another term instead of architecture. But as of today, we have a common belief that it's a thing like architecture, and architecture matters, and that's why we are taking architectural decisions. And in our architectural discourse, or in general in software discourse, we focus mostly on this highest triangle in this pyramid. For example, we have a set of books. My favorite one is by Andrew Harmel Lowe about facilitating software architectures, where he introduces a concept how to make decisions more inclusive, more democratic, more meritocratic. But we have not much about agendas and beliefs. And today I will try to dig one level deeper into this pyramid to the level of agendas with an approach Sociotechnical Engineering. I have another talk in preparation about how to dig even deeper to the beliefs, but first of all, I want to explain how these two layers can work together. Important thing is that in the recent years, the word or the term socio-technical has become established, but everyone means something different when they say it or when they hear it. That's why I would like to explain today what exactly I mean under the word socio-technical. First of all, we have to differentiate between two words where the word socio-technical appears. The first word, and the original one, appeared in the 1960s, been introduced by Eric Triest, who has investigated the coal mining in England. And his concern was about how to increase the efficiency of coal mining by acknowledging human factor. So basically, socio-technical in that context is about collaboration between humans and machines, mostly in workplaces and service design. For example, if you're designing a car or the car steering, you have a collaboration between human and the machine. Both humans and machines have vision. For example, the car can see something, the driver can see something, so they have some redundancy in this function, and in other functions they have complementary aspects of their work. And this collaboration, how they cooperate together to drive the car, is what this socio-technical world is all about. What I would like to talk today is another world, the world of our software projects, where we have people and artifacts we create. And in the sum, they comprise socio-technical systems. And under artifacts, I mean not only code, but also everything we create, like UX designs, business case presentation, requirements, documentation, basically everything. I would say that the totality of artifacts we create, we can call it technomatter. And techno-meta actually matters. So the question is, why do socio-technical systems matter? Why should we consider them holistically and not independently as social structures and technical structures? And the answer on this question lies in one sociological principle called socio-materiality, which says that people and artifacts are interconnected and have agency upon each other. So basically, it is obvious that we people have agency upon artifacts. We create them, we update them, but also artifacts have agency upon us. The easiest example is the traffic light. If you see red, you usually stop, I hope. If you see green, you usually go. Another example is law. We can easily kill each other, but we don't do this because we are usually following the law. Or another example, which is probably most relevant for you, are coding conventions that nudge people to write code in a certain way and don't write in another way. So you see the artifacts have agency upon us. They're not passive objects we create. They're also agents of power. And there is a common quote which says architecture is frozen music. I like to extend it by saying that artifacts are basically frozen power, and all artifacts, not only code. For example, if you are working in medical devices or aerospace or automotive, so the context where you have also embedded part and where there is a lot of regulations, in that case, the code is not the main character. It's not the main superstar among artifacts. It is rather yet another level of specification where other artifacts are usually even more important than code. So that's why I would propose to look at all artifacts and how they influence us in their totality. The most common manifestation of the social materiality is the famous Conway's law, that the structures, the social structures and communication structures used to become congruent over time. But as I said before, this is just a small part of the social materiality domain, because artifacts can emit power, they can transmit power, they can even resist power, and they can even absorb power. That's why social materiality is a very, very wide principle that has a lot of potential for software organizations. And today I will use this principle for sociotechnical engineering. So if you already heard about sociotechnical something, you have probably heard about sociotechnical architectures. So the focus of this subdomain is to find an alignment between organizational structures, business domains, and technical systems. Like DDD, team topologies are within this concept of sociotechnical architectures. Basically, what people usually aim at is find a team which is responsible for the software component A, which covers some business subdomain B. This is kind of perfect manifestation of sociotechnical architectures. This is already a very big thing. It is already recognized by InfoQ Software Architecture and Design Trends report as an early adopters. So this is already acknowledged thing in the mainstream. That's why I will not talk about this today. There are plenty of other speakers that give talks on this topic much better than me. I would like to introduce another concept, which I call sociotechnical engineering, with another focus to apply principle of systems engineering for sociotechnical systems. Of course, sociotechnical systems are emergent, they are not deterministic. We cannot design them like technical systems. But what we can aim at is designing conditions where the socio-technical systems evolve in an expected direction. So here's the idea. It is very simple. Socio-technical systems are its end systems, and we can engineer them like other systems. And what is systems engineering is all about? it is about basically three main categories. We have requirements, we have design, and troubleshooting. And in the remaining part of this talk, I will introduce these main categories of systems engineering applied to the world of socio-technical systems. So let me start with requirements. As you know, there are functional and non-functional requirements. The functional requirements specify what the system should do. For example, if I want to travel from my hometown, Bruchsal, to London, I ask the system to deliver some functionality. It is a functional requirement. The non-functional requirements, they qualify the functional one, for example, by specifying the modality of transport. And we can have even functional and non-functional requirements also for our socio-technical systems. Let me show you a couple of examples. So let's start with functional requirements. Let's say we have a functional requirement. We want to reduce costs by 30%. It sounds like a business requirement or a social requirement, but in reality, its solution space is not only social, it's also technical, because you can't fire just 40% of personnel and have a working socio-technical system. You can have to also to address this change in the technical domain. That's why this requirement is not purely social, it's not purely technical, it is socio-technical. And it is important from my point of view to put requirements like this to bring social decision makers and technical decision makers to one table to discuss their solutions holistically, both in social domain and in the technical domain. Another example would be we want to build a platform for other products. This one sounds like a technical requirement, but in fact it is even more social than technical, because depending on this platform, it will also specify the team responsibilities and interaction styles between teams. Think of team topologies. So requirements like this, they're also realized not only in social space, not only in technical space, but both in socio-technical space. And it is important to formulate requirements like this to align social and technical decision makers. Now, the most interesting part are the non-functional requirements, because they are usually more relevant for the architecture than functional ones. Let's start with a couple of examples. You know for sure classical non-functional requirement like availability. We can also introduce development availability requirements. For example, we want to be able to make technical decisions without relying on a single person for approval. If you ever found yourself in a situation where you sit in the room with your colleagues and someone says, guys, we cannot make this decision because our lead architect or project lead is on vacation. So this is not good. It's also not bad. It just means that the system that provides service of, for example, lead architect is currently downtime. It's not available. And you will not be able to make it available if you don't introduce such requirements to raise awareness about this project problem. Another example is scalability. We can also translate this requirement to the socio-technical realm and say we want to increase productivity by hiring more people. This sounds very obvious, but what usually happens in the reality that you hire more people and become slower than before. It sounds very unexpected, but it's actually the most natural thing that can happen, because scalability, like any other feature, it comes with a cost. And usually people don't pay for something what they don't need. And if no one asks for scalability upfront, people who make social decisions and technical decisions do not incorporate this quality into their system. So they don't design for scalability at the beginning. That's why we don't have usually inherent scalability in our socio-technical systems. And as a result, if we hire more people, we actually become slower, because scalability comes with a price. And if we introduce requirements like this, we will be able to discuss, okay, let's decide now for scalability instead, for example, for latency. So this requirements like this, they can help as a baseline for socio-technical decision making. Another requirement is a classical financial and time constraints. For example, if someone says our budget is 2 million euros and time to market is 3 years, it is completely different if the budget is like just 10,000 and time to market is just 1 month. And again, such requirements can help to avoid what is from time to time called architectural absolutism, when architects say, I want to use this solution because it has proven itself as a good, proper solution. Let's do it again. So the architects deliver solutions that are not related to the context of the requirements. And requirements can help guide them or at least ground them as a structural navigation for decision making. So let me conclude the part of requirements. The idea is very simple. If you want to design something, be it a technical system or socio-technical system, it's better to know what you want. And requirements is the best way to list your wishes. If you have socio-technical requirements, you can align social and technical decision makers. You can also look if some requirements conflict with each other. For example, scalability and latency, performance also conflicts with security and so on. And you can decide which one are more important than another one. So resolve conflicts among requirements. The next part is design. So systems engineering has 3 main categories: requirements, design, and troubleshooting. Now we are going from requirements to design. Here's a very simple idea how to translate system design to socio-technical systems. Basically, system design is about making arrangement decisions about systems elements. And if you understand what the system elements are in socio-technical systems and what are the possible arrangement decisions, then we get basically a design language for socio-technical systems. Of course, I have to mention that it is not the design language, it's just a design language, because we can create many of them depending on what we want to express by this design language. And after this, we can even take tactics and design patterns from our disciplines, because we have lots of books on tactics and design patterns, where people solve requirements like scalability, availability, and others, and reinterpret their solutions, their patterns for our socio-technical requirements. We will come to this later. So let me start with system elements. What could be elements in socio-technical systems? I believe that in socio-technical systems, usually organizations, people work on artifacts according to their roles. And these three words give us the main entities for the socio-technical systems. We have people, like here, physical persons, like Cassandra. They work on artifacts, for example, software architecture documentation, according to their roles. For example, the role lead architect is allocated to Cassandra. And I deliberately say that the role lead architect is allocated to Cassandra instead of the classical usage of saying Cassandra is a lead architect, because if Cassandra goes on vacation in this left notion, then basically Cassandra is away, the lead architect is away, we have nothing but to accept the situation that we don't have lead architect right now. If, however, we say the role of lead architect is allocated to Cassandra, then we completely reframe the narrative. What does it mean is that the service of lead architect is currently downtime. It is not available right now. But through this narrative, we can start a discussion, oh, maybe we should run this service on another instance. Or maybe we should always run this service on a couple of instances. By instances, I mean physical people. Or maybe we should completely redesign this service that we never run into the situation that if someone goes on vacation, then it becomes unavailable. So I mean, getting rid of the role of lead architect and redesigning it completely differently. So that's why I prefer to say that the roles are allocated to people instead of saying that someone is lead architect, someone is Scrum Master, someone is developer, and so on. And we can define the roles not by saying what people in this role are expected to do, but to saying what this role is responsible for. For example, we can define the role of lead architect just as someone who's responsible for the artifact software architecture documentation. And for example, the role of software engineer could be defined through the responsibility for the code in component C, but this role is also a stakeholder of an artifact software architecture documentation, and so on. And we can use this small, simple language to create large diagrams of roles, artifacts, and people, like in one mapping. For example, you see here in the diagram in the middle, an artifact software architecture documentation of the product X. This artifact defines a role of lead architect responsible for this product. This role is allocated to our Cassandra, but there is also another role, software engineer, which is stakeholder of this artifact. This role of software engineer of team Y is allocated to 3 physical persons, basically 4, also to Cassandra. So Cassandra is a physical instance that runs 2 services, lead architect and software engineer. And this artifact is relevant for another artifact, code, where the role of software engineer is responsible for. We have also other roles like platform architect, QA engineer, product owner, who are also stakeholders of this artifact software architecture documentation, and these roles are also allocated to some persons. And by using this diagram, for example, you can look, well, there is a Kate. She runs the role of product owner who has some interest in software architecture documentation, and Cassandra is currently responsible for this document, which means that Kate is Cassandra's client, or basically any developer, any engineer is a client of software architect. And basically Cassandra, while doing her stakeholder management, could run through all her clients, ask them what they expect from this artifact, and then work for them, basically. So such mappings can help facilitate stakeholder management in an organization. They can also help to understand where are the information flows in your organization. Because if you see something like this, then you know, okay, there must be some information flow between Eva and Cassandra. So you can trace your information flows. So these were elements. Now arrangement decisions. I believe there are 3 atomic types of decisions, arrangement decisions in any technical decision. So first of all, it is the composition decisions. For example, how to split the system into system components, or how to split our organization into teams. And when we split it, the question is how we integrate it back. For example, in case of components, do we need some middleware? Maybe they can call each other synchronously, asynchronously, and so on. In case of teams, the question is how do we integrate them? Maybe establish Scrum of Scrum, community of practice, some weeklies, and so on. These are integration decisions on the social level. And the third part, atomic type of decisions are allocation decisions. For example, which component, where should a component run on your smartphone, in web browser, maybe in the cloud, on premises, and so on, or which person goes in which team, or how do we allocate the role of lead architect to whom. These are allocation decisions. And now, given the systems elements and the way how can we arrange them, we've got a design language for socio-technical systems. And again, I want to highlight, it is not the design language, it is just one design language. But we can use this language to communicate our decisions. We can use this language to discuss them, compare our decisions with requirements, if they satisfy requirements or not. But we can also look upon patterns and tactics from other disciplines and reuse them for us. So the idea is very simple. Instead of making our socio-technical decisions from scratch, we just pick some from the tactics and patterns books from software architects. Let's take an example of availability. Our old scenario, we want to be able to make decisions without relying on a single person for an approval. So this is a classical availability case. If we open just one of the architecture books like this, Software Architecture and Practice, we will find there are 20 or 30 tactics, availability tactics, which are even broken into a tree. Of course, not every of these tactics is suitable for our scenario, but first of all, we can use this list for inspiration and ideation. And second, if you pick something from this list, like shadow, and we say to our colleague, let's apply the shadow tactic, then other person would already understand more or less in which direction it goes. So that these tactics, they also facilitate communication about solutions. I will pick a couple of these tactics for our case. First of all, the most obvious one tactic for availability is redundancy. Concrete redundance pair. We can say, let's allocate the role of lead architect to two physical instances, to Cassandra and to Hector. It is very obvious that redundancy is one of the solutions to availability, but it also means, like in the case of technical systems, that if there is no way to partition work between two working nodes, then these two working nodes have to somehow synchronize with each other, which means that none of them will be as efficient as if they would be by working alone, because it actually means that Cassandra and Hector should go to the same meetings together, they should discuss their work every day, they should align every day, maybe even work on the same artifacts together most of the time. So both of them will be not as efficient as if they would work alone, and it is something that they should acknowledge, because if the requirement says we need availability and not personal efficiency, then this is the way to go. So it will be much easier to get the buy-in by these two human instances to apply this tactic. Another example is a combination of two tactics, self-test and removal from service. Self-test is basically the system test itself, if it satisfies some requirement or not. And removal from service means that we just pull the plug and see what happens. And we can formulate these two tactics in a classical Gherkin-style test by saying, given the allocated lead software architect is on vacation, when an external software architecture audit for the project is requested, then the audit should not result in any major findings. And the nice stuff about such tests is that we can run them. Basically, we can wait until, for example, Cassandra goes on vacation or becomes sick. And in this moment, we can request an audit and see if the audit result in any major findings. If the test is green, then it's fine, everything works. If the test is red, then we have to troubleshoot. Maybe redistribute the role, maybe clarify the expectations, but we need a red test to take action. So that was the idea behind design, that we can find a design language for socio-technical systems to express design, communicate it, discuss it, and verify designs against requirements. Now the final part is troubleshooting. And of course, there is no single algorithm how to troubleshoot any problem, any bug in any system. But I think there are a couple of more or less generic principles of troubleshooting. The first principle is that bugs are relative. They are relative to requirements. If there are no requirements, then there are no bugs. Which means that if someone says that, oh, we are too slow, for example, someone says this in the retrospective, we are too slow, I expected us to be faster, this is not a bug yet. It's just a perceived bug. Because no one said that we should be faster. If you don't have any requirement on our expected velocity, then being too slow is just maybe it's okay. If maybe there was a requirement on delivering proper quality, then it is fine that we are sometimes too slow. So this is not a bug yet, unless you have requirements. Another example, if someone complains that we have too many meetings, well, this is not a bug yet. Maybe we are trying to achieve availability through redundancy, and meetings are basically synchronization tools, and it is fine in that case, unless we have some requirement to increase individual efficiency. Which also means that if we have some perceived bugs, they are not bugs yet, unless we introduce them as requirements. And if we change requirements by introducing new ones, we have, of course, to rerun our prioritization. Maybe these new requirements conflict with older ones. Maybe they're less important, and then we just skip them. Maybe they are more important than older ones, then we would have also to change the design of the socio-technical system. So this was the first principle. The second principle is what Russell Ackoff said, that in complex systems, there are not only problems, but there are messes, that are systems of interconnected problems. And instead of trying to solve problems, we should be aiming to dissolving the messes that generates those problems. What does it mean exactly on our example of too many meetings problems? What maybe some of us observed in their experience is that people try to solve the meeting problem, not to dissolve the mess. For example, one says, let's make meetings more efficient by appointing a moderator or sending an agenda up front. Someone says, okay, let's cluster all the meetings in the morning to get more focused time for engineers. Or someone says, let's allow people decline meetings if they have nothing to contribute. These are all brilliant painkillers for the bone fracture, but they don't heal the bone fracture itself. They don't dissolve the need for meetings. And I believe the answer to the mess would lie somewhere in a socio-technical architecture of the system. It could be the following situation, that there are two components, component 1 and component 2, that have technically high coupling. There are two teams, team A and team B, each of them responsible for these components. The role of team A engineer is allocated to 3 people, and the role of team B engineer is allocated to 3 people. And because their components are highly coupled, of course, these two teams will meet all the time, because none of them can make any decision without asking another one. So this could be the reason of the mess. And the solution, or this solution of this mess, could look like this. One says, for example, well, these two components are highly coupled, then let's merge them in one bigger component. Let's make just one team responsible for this bigger component and allocate it now to four engineers. And let's make another team now be allocated to just 2 engineers and make it responsible for another component. Or maybe we just say the team B is not responsible for anything. They can go and eat ice cream. It is basically implementation detail. So that was the final part, troubleshooting. If you liked the ideas of socio-technical engineering, I'm currently working on a book about it, where I will introduce this concept in more details with more examples. First of all, more tactics for different requirements. So if you want to learn about it, then stay tuned. Maybe next year the book will be finished. Now the question is how to apply these ideas in the practice. I would recommend starting with people and artifacts and roles mapping. First of all, trying to list all artifacts that the project is expected to deliver. Not only the code, but for example, requirements documentation, test plan, test execution plan, UX designs, business case, like everything. Once you have these artifacts, it is easier to define which roles do we need, because in this notation, artifacts define roles. And once we have roles, we can think about how to allocate this role to people we have, or which people do we need to run these roles. Second thing, we can gather functional and non-functional socio-technical requirements like we did before. There was just a couple of examples, but in reality, there will be much more socio-technical requirements in your situation. And like with technical requirements, I would also put them in some requirements documentation artifact. It shouldn't be necessarily like some PDF and SharePoint that no one reads. It could be just a collection of Confluence pages, or some Git repository, important things that everyone in the project has access to these requirements. They can look up the requirements, they can comment on them, review them, and so on. And after requirements, you have, of course, your design part, where you would also document your socio-technical decisions and then verify them against requirements. You can also resume reuse patterns and tactics like we discussed before. And similar to requirements, I would recommend putting all the decisions in socio-technical design documentation. Again, it must not be necessarily just PDF or Word document that no one reads. It could be, again, put in on the wiki or in Git repo. You can also put socio-technical ADRs, architectural decision records, like we allocate the role of lead architect intentionally to multiple persons to get some availability in the system, because availability for us is more important than personal efficiency. So these are kind of decisions that you can add, that you can put into the design documentation. I would also recommend doing the initial creation of these two documents in one workshop, where you gather all the requirements and maybe first designs with your team or relevant stakeholders. If you need to run such a workshop, feel free to contact me. I will be happy to help. And the most important part is that since the artifacts define roles, people often ask me who should be responsible for these two artifacts. And I would say it would be nice to introduce a new role of lead socio-technical engineer as someone who is basically responsible for this socio-technical requirements documentation and socio-technical design documentation, and basically makes a mixture of social and technical leadership. You can also practice socio-technical engineering not only in the workshop, but also continuously throughout your project, like you do with requirements engineering and architecture stream. And if you find yourself in a situation where you have some socio-technical bugs, you can also solve them by applying two principles that they're relative to requirements, no bugs, and that it would be much better to resolve the messes than to solve the problems. So that's actually it. If you want, I would like to stay in touch. Under this QR code, you can find all my social media profiles. I have LinkedIn, Blue Sky, Instagram, my personal website, where I put some ideas on the blog. It's complexitynavigator.rocks, but you can find it under this QR code. And yeah, that's it. Thank you very much. And I see that we have plenty of time for questions and discussion, if any.
Awesome. Thank you very much for this. It was a very unique topic. So far we never really had people talking about this, and I think you highlighted on a serious issue within the software engineering space, namely that companies spend a lot of time in designing the architecture of their code, right, and writing clean code, all these things, but somehow they or we spend much less time on designing this human interaction and these socio-technical concerns and things. So yeah, great job. But I really like that removal from a service practice, and because let's say we remove one person from the flow, and let's see what happens, right? And nowadays, or usually, there are a lot of heroes in the teams, and if any of them are sick, or they go for vacation, then things are stopping, right? So I like that practice. This is a great fun. So yeah, thanks again. We have plenty of questions, so I would say let's start checking them out. Let's see. The first one is, let's see. So the question is, we often don't know the requirements upfront though. How do we deal with that? And maybe we don't even realize we have a new requirement during the process because we are not aware of it enough. So how do we deal with that when we don't know the requirements upfront? So what is your experience here?
I would say this question is not specific to socio-technical systems. It is also a general question that requirements change, that we learn about them with the flow of time. And if we don't do any requirements engineering at all, we will end up in a mess rather than we do some of requirements engineering, like collecting the requirements that we know as of today, try to meet them with our designs, and if the new requirements emerge, then we reprioritize them and see how can we adapt our design to the new requirements. But by deliberately making requirements engineering, we are better off than by not doing this, both for socio-technical and for technical systems.
But in agile context, you would say, well, we have our user stories and we don't have requirements anymore. What do you think about that? The requirements is something old. We don't need that anymore.
I think the requirements and user stories are different things. The stories are just the form and requirements are the content. The user stories are just another way of manifesting the content of requirements, but in the end we have requirements, and the question is if we write them down and communicate, or we just invisibly follow them.
But can the system not emerge the design, let's say? Do we need to have all the requirements up front, or is it okay if we have just some requirement and then the system evolves however it evolves?
Yeah, I think like with a function, like with a technical requirements, they usually emerge over time. And if someone just figures out, oh, we have the situation, we want to speed up the project, but somehow hiring more people will not make any sense. So this is something that we realize afterwards. But I would use this situation as a point when we introduce this requirement to bring the lead architect and the project lead together and to discuss how we achieve this, and then documenting it. Because if we just hire more people without communicating this socially and technically, then it probably will not work.
Right. Yeah, great discussions, great answers. If nothing else to be added, then I jump to the next one. From the same person, we have a lot of questions from the same person, so let's see. We are happy to see such interest. So the next one is, such roles, artifacts, people mapping does add work though, right? Making them, updating, discussing, etc. So basically, what means that, yeah, I mean, this really requires effort and work. So what is your take on it? Is it how much work it needs? I mean, this was Sociotechnical Engineering. What's your experience? So what is your take on it?
Well, we did it a couple of times in the retrospectives, and like any other design work, it was collaborative exercise for our team. And it it has created better shared understanding of who is responsible for what is the scope of our project, not only code, but also what other things we have to deliver. And like any design, we can see any design as an additional effort but we do design to clarify something for the future. And the question is just if this investment worth it or not. And for us, it was a good investment.
So
Yeah, go for it.
go. Yours.
I mean, I guess you have tested these ideas, right, in real life. So, what is your experience? Which are the practices which really work? Which are the practices which didn't work very well? I guess you did also retrospective on that, right? So, or maybe all of them worked pretty well. So, what is your experience here? What is your, how do you feel about this?
Well, this ideas of sociotechnical engineering are more or less new, just 1 or 2 years. They are not yet established. That's why it is impossible today to come and say, I am a lead sociotechnical engineer. We will be doing full sociotechnical engineering. What is possible is what I did practice is to do this bottom up. For example, if I've seen that lead technical architect navigates his discourse only from the technical perspective, like saying, oh, let's use relational database because it is better for the data consistency. And if I saw that this might jeopardize our social setup, because one relational database means that someone has to understand all the relations, all the schema dependencies, and it would end up with the lead architect being the only person who understands stuff and becoming a bottleneck. In this situation, I would kind of make a couple of steps to the left and say, okay, let's understand what is good for the team from the socio-technical perspective. Do we want to have one architect as a bottleneck, or do we want to have more independent, more distributed role of the architect? And by doing so, you can introduce these socio-technical requirements in a very subtle way without having a mandate of the big lead socio-technical engineer.
Very good.
So, I mean, it sounds a little bit like a team that you would work with has lots of roles and people as basically have that role, and those roles are usually somewhat, I mean, associated with some form of power, of prestige. I sometimes have seen teams where those roles don't actually really exist. Everybody is doing a bit of everything. I mean, it sounds a bit like it's more for larger companies, maybe, or also a bit hierarchical companies, maybe, or is that just my limited understanding so far? Or could you apply sociotechnical engineering also to these more, let's say, well, our role is devs, and sometimes we take the role of architect and we discuss that together and build the system together, kind of teams?
Yeah. So I believe it's not more about hierarchies and prestige, but simply about understanding the responsibilities and who are stakeholders of whom. And of course, if you have a startup or just small team, everyone is just engineer. And there's a thing that is different in that case, that you just have, for example, one role of team A engineer responsible for a range of artifacts. Maybe there are 10 of them, like code, CI/CD scripts, test cases. But even in that situation, it is just another architecture. But you can still use this language of, okay, guys, let's collect all the artifacts we have to deliver, because it already helps the team to understand their scope of mandate, and then to assign roles. Maybe everyone will be just responsible for everything. Maybe there will be some people who are responsible just for the test cases and so on. But this is will help, I believe, to facilitate the communication and stakeholder management, even in the team.
I just imagine that if you have some lead architect who's doing that for years already, when you come with that idea and say, well, it's a role, and actually there should be more people that actually have that role, especially if you are, I don't know, go on vacation or something, and then he's like, well, yeah, maybe, but actually that's my role and I don't want to split that up. I mean, I can imagine that people are like that.
I will jump back to this slide here. So it is about framing the narrative. If you see this I would say old patriarchal architect, you can start framing the discourse by saying, "Oh, our lead architectural role has downtime. What can we do about it?" This raises awareness about some malfunction in the system. Because if someone says, "I'm the lead architect, if I'm on vacation, that's fine, just accept it," it doesn't sound like a malfunction of the system. But if you change the narrative, raise awareness among other people, then you are kind of preparing revolution. It will be easier later on to make this shift and start doing mapping like this and seeing, okay, are we going to increase the efficiency of this God architect, or are we going to increase availability of the role?
But I assume, I mean, just imagine you had somebody like that, they will probably still say no. So you basically need to persuade those people above them, or that make the decisions about those things, about how many lead architects we're going to have, or something like that. I mean, it can be also associated with, with money, basically. So you pay more for somebody that has the role of lead architect. So that might be an issue as well.
Yeah. I think every change begins in the heads, in the beliefs and comprehensions. So of course they will push back, but by creating new narratives, you, so to say, extend agenda and focus not only on technical decisions, but about socio-technical problems. And these narratives will, over time, create new beliefs that something doesn't work well. And if 10 developers consider this architect, this allocation of the role to single person as a malfunction, then it will increase the readiness, even for the architect itself, if he or she doesn't feel recognized anymore, to allow at least discussions.
And actually, I start to like that, because you can basically deliver the message that something is wrong. I mean, if you get hired, then probably somebody said, well, in our team organization, something is wrong. And then you can basically highlight it in a rather technical way with these diagrams, with these dependencies, and actually show it. It's not implicit anymore. So you actually have it in a diagram, and then you can probably reason much better about it, and they will actually also understand it. I mean, even technical people. That's my idea that I have here.
This is the motivation behind, one of the motivations behind this.
Yeah. Cool. So,
all right. Let's jump to the next one then, I guess. From Ulf, is there a list of socio-technical requirements or heuristics to ask for them? I think he means that, is there some patterns, or do you see some recurring, list of requirements, socio-technical requirements you could use in domains, in most domains? Or you mentioned that you have been involved in many different kind of domains, so I assume you could see some patterns, so some requirements, socio-technical requirements, which can be sort of applied everywhere. Or what is your take on this?
The answer to this question is no, but not because there is no list, but just because I haven't created it yet. But the idea, what I mentioned, that in the upcoming book, I would also aim for this list while creating the prototypes of classical requirements like scalability, availability, performance, reinterpreted in the world of socio-technical systems, but also classical example of functional requirements, so that other people can just look up and see what would be interesting for them or not, like a checklist. So this is a very good point, but it will come someday in a book.
hopefully it will evolve, this small socio-technical engineering, so there will be more and more materials like
So
that.
for that, I have the question: how do you prevent these documents from becoming other like Confluence documents that nobody reads? I mean, you do a workshop, you create those diagrams and everything, you upload it, everybody shakes their hands, and then the next day everybody has forgotten them. So how do you like ensure that this is a living thing and it actually evolves together with the team or organization?
Okay. I would say the answer is also more or less generic, that there is no religion without church, because the church ritualizes religion and reminds people, oh guys, we have God, we have God, and so on. So people don't forget religion. And the same, I think, is applicable here, that if we keep the narrative all the time going, like, oh guys, we are now in a situation where we have to make decision, and by the way, the decision is socio-technical, so let's look again to the requirement. This will ritualize the notion that that we have socio-technical requirements, we have socio-technical design, there are some ATRs, there are some mappings, let's look into them before proceeding. So we create a culture of socio-technical engineering over time.
So would you also like integrate it into any agile, what do you call them, meeting or something?
No. And you mean, and then sell certifications like certified engineer. then it's that immediately.
Then it's that, yeah, that is that true. Yeah, I just mean, it sounds great, but I see the issue that if we have to develop software, that we may at some point forget about it again, and then maybe it creeps back into the same thing because we're habit animals, and we need to repeat it over and over again, and somehow we need to make sure that we actually don't forget why we're doing it. I mean, that's the problem with Agile, that we forgot why we're actually doing it and we're just doing it so it's done. So how do we avoid that?
Yeah. Well, this is not an aim in its own. It's just a means to an aim. If it helps, then it helps. If it's obsolete ritual, then you don't need to use it anymore.
Yeah, be agile about it, right? Give it a try. If it works, if it helps, then keep using it. If not, then yeah. Or take what really works, use it, and what doesn't work, just get rid of. That's basically the promise.
Yeah, this so basically is the main motivation to align the water and the faucet between social and technical decision makers, because before it flows into this.
Okay. There is one more from the same person. I skipped a few questions, 2 questions of this person, but if I skip something which was not answered, please let me know. Otherwise, he says, most of my questions have been answered now. I was pretty critical at first, but I think better understand it now. It's a success, right? So we treat teams to be as software, make them flexible, for example, or adaptable. So what is your answer here?
I would say software as roles and people are infrastructure on which we can deploy the roles. And depending on our design, it will allow for flexibility, adaptability, and so on. I'm not sure if it answers the question. And if I'm also not sure if saying that people are infrastructure is humane or not, but in this socio-technical design language, people are basically worker nodes that run roles.
But that's actually also a bit my question. So when you run such a workshop, how do you make sure that people still feel like human beings and not like infrastructure?
Well, not using this words in this workshop. Just saying, okay, there is a role of test manager, and let's allocate this role to you. You are now responsible for this artifact. You are an owner of this artifact. It feels great.
And how do you? I mean, how do you deal with those patterns? I mean, I see those over and over again. The 10x developer and all the other developers are intimidated by that person and will not raise their voice, for example, say nothing against the guy, even if the guy's decisions are bad. I mean, these are also things that you could somehow engineer, but do you, in your framework here, do you have that already in mind, or is it just like the official roles?
Well, the example, when, let me see, where is this mapping was? Must be. Here. So let's say, I don't know, Chris is a toxic person, right? So if this means that there must be some malfunction in this system, like a perceived bug. It's not a bug yet because maybe we don't have a requirement for it, but in terms of this language, one has to find a narrative how to sell it as a social technical malfunction and raise awareness about it. Not pointing to Chris, but about pointing that Chris is responsible for some artifact, and this artifact doesn't meet expectations of its stakeholders, so that the service level for this artifact is pretty low. Let's think then what we can do. Then we will enter in this discussion. So you create this narrative using this language. But first of all, one has to very politely, deliberately find this narrative of socio-technical malfunction.
Exactly. That's I think is also the problem. I mean, if you start like pointing out, well, there is a malfunction, probably the other developers will not say a word, and the other one will say, well, in my perspective, there is no malfunction. Everything works fine. I don't know, what's your problem? I mean, how do you? I mean, I just mean like this. I can see how you can apply it when people agree and when it's like more or less a functional organization and they're like, well, we have some problems and we don't know really where, and now we want to like improve ourselves. But if you have those really like bad things where you basically are on a level where you first need to get the team to basically work together correctly, I mean, is this already applicable, or is this like well, need other work there, need a psychiatrist first before you can introduce that?
I must admit I was never been in such situation, but so in theory, for example, Casey is not happy about Cassandra, and instead of saying Casey is not happy about Cassandra because it is too personal, one can frame it that the artifact software architecture documentation doesn't meet the expectations of one of its stakeholders. Maybe everyone on this side is totally happy about this artifact, but Casey is not happy. And then, like with any other artifact, like this code review, if someone is not fine with the code, they put comments or so. So there are more or less humane, civilized method of resolving conflicts.
Have you had something like that already in one of your workshops?
You mean such conflicts?
Well, some conflict that actually only emerged once you drew the diagram and played around with the roles and the artifacts.
Basically, no.
Yeah.
We just rather get better in understanding who might need something from another person by drawing the map of artifacts and looking who is making what, and then kind of creating a matrix of dependencies and concerns.
Mm-hmm. Okay. Yeah.
But it would be interesting to see if one can resolve personal conflicts with this. I think everything what is made collaborative modeling would already kind of make team a team.
I just thought of CRC cards, like class responsibility, collaboration, and then you could actually apply that as well to there. If you have like one God class that has all, or one God, what would that be? Person, people, yeah, person that has all the roles assigned, and then you would also see, well, maybe we need to split that up a bit.
Yeah. If everything is assigned to consultants, this worker node will crash someday. Yeah.
Okay. Great discussion. Let's see the next one. A very good question from Lina. I like it pretty much. She asks, do you think architecture should adapt to the structure of teams, or should teams adapt to the architecture? Thanks. So what do you think of this?
Yeah, both. I think this classical team topologies question, where we have to find an alignment between teams' social and technical structures. So basically, holistically in both directions.
Okay. How would you start such a process to find out these things? Let's say, okay, no, this is the answer is basically to figure out and to align between the teams and architecture. So how would you figure out these? What would be the first steps?
In my opinion, first steps are gather all artifacts. But this is kind of our to-do list for our organization. It's not only the running system, it is basically everything we are expected to deliver. And when we have the artifacts, we can start finding what roles do we need, and then seeing to whom we can allocate them or reallocate and so on.
So if the artifact is a big old legacy application where 90% of the people that build it are already not in the company anymore, how would you approach something like that?
Well, it is just implementation detail which will result that the service, that the role who is responsible for this artifact will not be allocated to very efficient persons. But it doesn't mean that this language is not applicable for this situation. It just means that, there is specific situation, let's look to whom we can allocate it, but at the end it's just an artifact and there is a role behind.
So the roles then would emerge like, okay, I need somebody that actually can architect that thing for me. I need somebody who has written tests for that thing. I mean, I try to, like, if you say, okay, we start with the artifacts, okay, how do we get to the role? Is it like you take a set of roles that you already have, like classical roles, and assign it, and then you see who is actually in those roles? Or how? I mean, I'm still trying to piece it all together so I can apply it as well.
Yeah. So once we did it, it became clear that in perfect case, it would be much better to define roles after we define artifacts. But since most organizations have already predefined roles, even Scrum Master, people ask me, what is Scrum Master responsible for? And then my answer is, who said that we need Scrum Master? It is workaround. Because in software organization, you're going to deliver artifacts. If someone is just going and talking and enabling something and doesn't create any artifact, it just says something about our architecture, and the Scrum Masters raise a workaround to keep the things running. But anyway, so we found ourselves in a situation where we have already roles of lead architect, engineer, test manager, and we found a good match between these roles and the artifacts we created. Of course, we had much less granular roles than one role per artifact. For example, the test manager was responsible for testing documentation, test execution plan, testing report, and a couple of other artifacts. The lead architect was responsible for the software architecture documentation, software design documentation, and a couple of other artifacts. But we were lucky to find some mapping between the roles and the artifacts. And I hope someday, maybe in 5 or 10 years, if these ideas get more proliferated, then it will be easier to start to make such things up, also not upfront, but at least before defining roles.
Or you redefine the roles. I mean, if the company or the team is open to redefining it, then maybe that, well, that's exactly what I mean. A role is associated with some form of prestige and power. I mean, people don't want to let go of their role, I can assume. So introducing new roles or being less responsible for everything, that can be quite hard.
Yeah. So the example I referred to was in medical devices company, and they already had a standard operating procedure for running projects. So they already had concrete roles. You can't change them, but within our team, we just make some sub-specializations.
Yeah.
Okay, let's see the next one. The question is, can the devs be stakeholders as well?
Yeah, sure. So they are. So in this example, software engineer is supposed to be a dev. And because they're responsible for, let's say, artifact code and software architecture documentation is relevant for code, they are basically the stakeholders of the role lead architect. They are clients of the architect. We used to say that architect is some higher up and engineers are like smaller people, but in this notation, engineers are stakeholders of the architect.
Okay. So yeah, it's clear, yes. It was just not that clear. Okay, cool. Very good. Very good one. I would have a question, namely that, I want to get some more experience about this. So what's one socio-technical decision that you made in a team that had some surprising long-term effects, both positive or either positive or negative? So do you remember any of them which really had a surprising long-term effects? Would be nice to have both a positive and a negative example, but if you just can give one, it also would be nice just to see really in experience that how these decisions affects the team or a team performance or something else on the long term.
It's hard to recall it spontaneously, but I can remember some unexpected positive effect of disrupting a hierarchy of corruption. So what we had in a project is what Oli already said, this classical patriarchal architect who hiding information, trying to make decisions fast and alone without communicating them. So it was really, really negative behavior. And as they worked for another service provider who kept a couple of people around software architecture, and they tried to present their decisions as positive. And if something didn't work out, since they were the ones who reported it, they of course could finger point to someone else. So this was a setup, and over time, I was lucky to disrupt it. And at the end, all these people were fired from the project, which sounds very evil, but it was good for the project. And the idea was very simple. Any corruption works in the asymmetry of information. So some people know something what other people don't know. And in that case, it was just making decisions and presenting them in one light and hiding completely the process of decision making. And what I started to do is documenting some decisions afterwards. So it is something what no one recognized as a danger, because you are just a nice guy offering, let me document this decision afterwards so that we have a documentation for the people that come later. So step by step, you create a culture of documenting decisions. And once you have a couple of them, people start to believe that it is okay to document them as ADRs before we make them. So it allows for this political shift that we not create the decisions post-mortem, but basically involve people in the reviews of these decisions and so on. And once we established this culture and create a more meritocratic and democratic process of decision-making, these toxic people, they were immediately obsolete. It was more clear how their misbehavior was destructive for the project.
Mm-hmm.
And over time, they became obsolete, and then it was recognized by the project leadership that they are actually not helping.
That's a good outcome, right? I mean, when they realize such misbehavior.
So they eventually got rid of them from
Yes.
Okay.
So afterwards you had sliced tires or so?
Sorry?
You had sliced tires at home or so? Or threatening letters sent to you afterwards?
No, exactly. It was done without any conflict.
Yeah.
It was very subtle, peaceful creation of the artifacts, creating culture, creating religion, and then creating a new church around this religion.
Yeah, and it's a rational way to do it. I mean, the issue probably with if you address it on a let's say psychological level or so could be that people are like, oh no, now it's the guy that just wants to talk again comes into our team, and this can be like putting off for people that are not really emotional but more like rational in their mind. And I think this is a completely different approach to basically sometimes the same problem, I guess. It's like, well, we just dissolve your system. We will just lay out how it looks like actually in components that you can understand, and then you probably will see the issues yourself. And that I actually like that a lot. Yes.
Okay. We have one more question here. Let's see what Lina asks. Just wondering, even if roles and responsibilities are clear, who makes sure the artifacts stay consistent over time when people or roles change? Should architecture take care of that too? So what is your take on this? Who maintains these things? And when people and roles change over time? So
basically we have 3 points, 3 types of change in this language. We can change. People change, role change, and artifacts change. And basically every such change, if got noticed, is a trigger to examine our diagrams and think again how to change it.
So who takes care of this? So I mean, yeah, we can use this mapping, make sure that we stay consistent with our socio-technical engineering patterns. But so the architecture should take, you mentioned that usually there can be a socio-technical engineer, right? But maybe we don't have money for that, or companies are still not willing to do that at first. So who could do this? It's still a collaborative effort, but still someone should lead this, right? So or maybe a consultant could help, or what is your take on this?
Well, you are right. The socio-technical engineering is not yet mainstream. There is no such roles as lead socio-technical engineers, but we can put such exercises either under the hood of the project leadership, just informing them about all this social materiality principles, or putting them under the technical stream where people would discuss such things in architecture weeklies, for example. Not optimal, but it is better than nothing.
Would you recommend having junior social technical architects and then lead social technical architects, or is that the career path that we can market at some point?
Well, in this notation, there are no senior or junior because these are just artifacts they have to create. they're old or young, it is implementation details. It is rather like, let's say this is a service instance with 256 megabyte RAM or 512 megabyte RAM. This is a difference, but the roles are the same.
Mhm.
I see. Okay, we have 5 minutes left, and there is one question which is really interesting from us, namely it's related to AI, right? AI is pretty useful and hyped as well, but they are very powerful, without doubt. So question sounds like this. How does socio-technical engineering integrate with AI systems? Can AI help mitigate problems of roles being associated with seniority and power, and the assigned people typically being unwilling to let go of it? So how does socio-technical engineering integrate with AI system? What is your experience with it? And whether AI can help to mitigate these problems of roles being associated with seniority and power? I hope it was understood.
Sorry, what with severity?
Seniority, sorry, seniority.
Seniority. Okay. Well, I'm not sure. So, anyways, I believe this helps create more democratic structures and replace hierarchies by networks of dependencies. I'm not sure what is the relation between this concept and AI, but what I believe is that today our role as people is mostly not about creating artifacts, but about aligning them. For example, the requirement engineer speaks to the technical architect so that the artifacts they create are more or less aligned. So we are mostly not, we are migrating in our positions from the role of creators to the role of aligners. And I believe that when we use AI today, mostly in a compiled mode, where in our work as, for example, developer, we just co-create artifacts. But things will change when our role as aligner will be replaced by AI. And this is only possible when AI will get access to all artifacts, so that it will be inherently aligning artifacts while they are created. And then we will, for example, we add new requirement in a system, like now I want the system to do this and this. And because AI integrates all the artifacts like UX design, requirement, architecture, code, it can test cases, it can immediately recognize how it conflicts probably with all the requirements, maybe some architectural changes need, maybe generating code, maybe saying that, oh, this requirement conflicts with another requirement. So in this moment, AI will become the tool of alignment, replacing our role of aligners. And then these diagrams will be completely different.
I see, but no, I totally understand. Great. Yeah, exciting times ahead, right? In terms of AI, and hopefully it will help also with the socio-technical engineering, and we can see how it will unfold and help to build better software. Well, yeah, again, that was it, and everyone, that was the session for socio-technical engineering. I think we had really great questions and exceptional presentation about this from an expert, Yevgen. So thank you very much for coming and putting this all together for us. And as before saying goodbye, let me introduce the speaker of the next meetup in 11th June, AI-assisted development with verification. So we will see how AI helps to build software from Jeff Langer. So looking forward, then stay tuned. And of course, again, you can join us on Meetup. You can follow us on the different social media platforms. And big thanks again to sponsors and partners. So again, Yevgen, thank you very much. Oliver, my friend, thank you very much. And everyone, for the audience, for staying here that long. And I wish you a great day further. And yeah, see you in the next one. Goodbye and thank you.
Guys, bye-bye.